In question 18, I'm given two formulas for energy, one for kinetic energy, one for potential, and we're told that somebody wants to analyse the velocity of an object, taking into account both its kinetic and potential energy. If we look at these two formulae, they've both got, well, the only thing they've got in common is m, the mass of the object. We're asked to combine the two formulae to express v. And when it says express v in terms of, that means I should get v equals, and then something, and whatever's on this side, it says in terms of p, k, g, and h, so the only letters that it can have are p, k, g, and h. So if we look back to the two equations, the only letter that doesn't include is this m here. So we need to eliminate the m, which we can do because it appears in both equations. So I'm going to make m the subject of both and put them equal to each other. The first one says k equals a half mv squared. How do I make m the subject? Well, times by 2, that would give me mv squared, and then divide by v squared. So 2k over v squared is equal to m. And then with the other formula, I've got p equals m lots of gh. So m equals p over gh. Now, if both of these formulas equal to m, then we can say that they both equal to each other. So instead of putting m equals this, m equals that, I can just say that 2k over v squared is equal to p over gh. So now we've got an equation that doesn't involve m's and only involves the letters that it asked us to express in terms of, but we need v to be the subject, so you need to make v the subject of this equation. So at the moment v is in the denominator, so I'm going to multiply by v squared, p v squared over gh, and now I've got to get the v on its own. So instead of dividing by gh, I'm going to times by gh, so 2k gh equals p v squared. To get rid of the p, divide by p on both sides, but I've still got v squared and I just want v, so I need to take a square root. So the final answer would be v equals the square root of 2k gh in any order all over p.